Hi guys, welcome to Tech Geek. So today we are back with a daily LeetCode challenge problem. That's Jump Game 6. That's basically LeetCode Medium 1696 question. Before beginning this, I'd like to request you all to please like, share and subscribe to my channel. In case of any queries, any questions, any issues with any upcoming placement sessions or any particular thing you'd like to know, do let me know in the comment box. I'll be there to help you out. Please join my Telegram channel, the link given in the description box, to know about the new updates of any videos that's coming up. If you want to interact with me regarding any particular interview process, then too you can ping me there. It would be easy and you'll get response within few hours itself. So let's see what the question has now. Okay, coming back to the question, they say that you have been given a zero indexed integer array nums and an integer k. So we have been given two things. You're initially standing at the index 0. That's the first element we are standing. Okay, I hope you can see now as we have to move. Okay, so we need to see that in one move how many jumps we can make. So in one move the integer k is the at most steps we can take. That means it could be 1 to k any steps we could take without going outside the boundaries of the array. Now you must keep that in mind that taking k steps won't let you move out of the array. So somewhere what you have to do is, if you are at index I, you can move from I plus 1 to minimum of these. So I'll just let you know this afterwards. So you can reach the last index and you want to reach the last index. So your destination is this. You have a score. Okay, your score is the sum of all the elements, that's nums of j, that you have visited. When you jump, so you have to sum up the elements and that would be your score. You have to return the maximum score that you get. Let's see some example. Let me explain you some one. Let's see, this is one. Okay. We have -1, -2, we have 0, then 4, then let's say it's 7, and let's take one negative, -5 and 3. Okay. So this is the array that's given to you and they are giving you an index. So sorry, the number of elements. So let's say the number of elements k. Here k is 3. Okay. So what does it mean? Initially you are at 1. Okay. Now you have a score. Score is the sum of all the elements visited. So initially the visited sum will contain the 0th element. That's 1. Okay. Now you have to see amongst the 3 jumps. That's among the next 3 elements you can jump on any one. Okay. So what we'll do, we'll take the maximum of this. So what you have to do, you have to take a sliding window kind of thing. You have to check. Okay. For us, this is the first window from which we need to extract the maximum. Why maximum? Because we need to get the maximum sum. So according to me, all both are negative. So this is maximum 0. Okay. Coming to the next maximum, that's the next window. The next window now will be remove the first one and take the next one. Okay. 4. So here maximum is 4. Next, let's come to the next window. Again we'll remove the first one and add one at last. Again maximum becomes 7. Now as we can see, again we need to move. We'll remove 0, take the next elements. Okay. Now see, this way if you are going, okay, just keep that in mind. If this way you are doing, you're going wrong. Why? Because in the sliding window we remove the first and then take the next ones. But if you do in this way, now this is where the problem occurs. That's what I wanted to tell you, that coming from here you took 7 as max, again 4, 7, -5, again 7 is maximum. So will you add 7 again? No. Why? Because that was visited once. So this sliding window is not how we need to prefer. How this window would be slided, let's see that. I hope this point is clear, like why we won't go with this one. Okay. We began from here. Now we'll check. The first step is again the same. From 1, you can take 3 steps. Like you can take any of these steps. You can take 1, 2 or 3. Okay, max is 3 until you reach the last. So obviously here the maximum is 0. Now as you know the maximum is 0, you won't take the sliding window like this. Now you will take the sliding window after 4, 0. That's visited one. Okay, that is what has to be clear. So it will avoid a repetitive visits too. Now you can see from this the maximum is 7. Now this is visited. So after this the node will be cancelled. So here the maximum is, and now from 3 obviously we cannot go anywhere. And yeah, in the second one we took a window of 2 because it was said we have to take less than this, or like 3 or less until we cross this, because if we'll take 3 then we'll move out of the boundaries. Okay, this is what it was. So while considering the sliding window concentration, you need to keep that in mind, that whenever you are going through this, you should consider the elements, that's the sliding window or your constraint path, after the path that is visited, and that should be either k or less than k from I plus 1, depending on the condition that it doesn't process. So now coming to this line that was given, that any index that is from I plus 1 to minimum of n plus 1 or I plus k. So this is what they wanted to say. Either take minimum of I plus k. Okay, let me show you this also. This was 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so this was it. Now you are here. That's 3. So you can go with 3 plus 1, that's 4, with 3 is k, so I plus k, that's 6. Depending on this, that n minus 1 and 6, which is less, so obviously 6 is less, so this is the window. Now coming to 5, I is 5, I plus 1 is 6, but n minus 1 is 7 and I plus k is 8, so which is less, 7, so that's why we'll take the minimum of this. So that's how you'll consider the window. Now what you'll do this with dp. This is actually what we did. We are creating kind of an array. We are storing the maximum sum of that particular I index. We'll keep that, we'll add it in this way. Okay, now let's see how this particular code will look like, how the process is. So what we'll do, we'll create a score array, that's TP. We initially have 0, 1, as I told you that we'll always consider the first one. Okay, after considering the first one, we'll do DQ, and we'll add the 0, 1. Again we'll check this. Now again peak of first and peak of last. Why? You can see how we were going in forward. Okay, why we are doing this? Because you know that you will store the index of the decreasing scores. Okay, you can see q offered 0. Okay, we'll store the index of the decreasing scores from I minus k to I minus 1. So we need to check this. Now get first, which we are using the peak first, this will give us the maximum score in score I minus 1 to score I minus k. That's how, and in the last step we'll get the maximum result. So this is actually order of n, just a single traversal, and you have your answer. So if in case any queries with the solution, any approach related issues, you can let me know. You don't need to make any particular case for the negative ones, as you're taking out the maximum. So maximum would be any of the numbers. Even if there are negatives, then it would consider the negative maximum. Negative maximum in the case, I need to say, like if you have a window of this. So obviously the negative maximum here is minus 1. That will reduce the negativity and increase the sum. Okay. I hope the solution is clear. If there's any doubt, please let me know. Comment in the comment box, and do let me know. Do join my channel too if in case there are any queries. We'll be there to help you out. Thank you.